Hello, my name is Arne Schmieg, and I'm presenting you an easier way to develop distributed applications, and in this case, games that are divided between multiple platforms, and you can play with others together. And the idea is that you use distributed objects and abstract over the messaging and RPCs and object replication that you have normally. I'm the lead developer of a company called Activator GmbH, and we only have this product. We have a product that is a distribution engine for objects, and basically we have to do with a lot of languages. This is just a small example of 2 languages that we support. And basically, those are the languages that I like the most. But we have C++ and stuff like that too. So what is this talk about? The talk is about the challenges and the problems that occur if you have a local game that you want to that you want to change into a multiplayer game, a single-player game into a multiplayer game, or something like you have something that you can play couch co-op, for example, and want to move it to multiplayer. And the first thing is there are games that are single player and use a server. Online games that don't even have multiplayer. And basically the challenges here are you have to think about how the communication between clients and server work. You have to think about circuit programming. You have to think about where to put the logic. Do you have server logic? Do you have client logic? There are multiple possibilities how to do all this. And today you probably want something like an offline mode where you can still be connected in some way to the cloud when you are in a mobile, in a train, and have no connection, for example. And those are only the problems you have if you have a single-player online game. Then, if there are multiplayer online games, you have something like you want fairness between players in a lot of cases. That you want so that different pings aren't so important for someone, and you have a lot of different devices that probably connect to each other. And today everyone wants to be connected with everyone, so it's not like, okay, I'm playing on an Android and another one is playing on an iPhone, and you can't play together. That doesn't work anymore. And basically you have to program in different languages and on different platforms. And another thing with multiplayer games is that if you have something where everyone knows everything, for example, in a room, and everything is distributed to everyone, then the amount of messages is increasing by player amount squared, because everyone gets every message. And then you probably need something that scales your system, and that's where a server cloud, what we call a cloud game, is coming into the game. And if you do that, it's getting really complicated, because you have to think about server deployment, something we heard today already. You have to think about distributed server logic, probably, what the inter-server communication is. And today, you probably don't want to have a game that is really distributed between rooms, but you want to have, for example, rooms, and you want a friends list that is over all servers, for example. So even if you have single servers that allow the scalability, you want to have something that is connected between the servers, so it's not that easy to scale in that case anymore. And you have to think about load balancing and stuff like that. So there are a lot of challenges that you face on the way. Those are just a lot of things that you have to think about on the infrastructure side. There are a lot of things that you have to think about. For example, if you want to have something that works everywhere, you have to think about how can I go through the firewall, and how can I push through an NAT, or how can I have an architecture that is working with all of those technologies, using the newest technologies to go through firewalls, to be scalable and everything, and still focus on the game to develop. So there are a lot of technologies that do stuff like this. That there are a lot of technologies for each of those cases, basically. But the problem is that even if you go down that road, you start with finding some technology that helps you for infrastructure, for transport, and for communication. But our thought is that the way that really is necessary to keep productive and be effective in developing in a game or a distributed application is that you have to abstract over all those things and don't think about how to do one of those big challenges, because the challenges are getting more and more actually, and there are more platforms each day and everything, and so the distributed objects and interest management and RPCs, this is the way we think you can abstract over basically everything that's below that. Because if you have really distributed objects, then all other stuff can be replaced with the best matching thing. You can basically use the best working, the fastest real-time communication, and still be using your distributed objects like you would program a normal game. And that's basically what we think that is the best way to develop something that is getting more and more complex, to abstract it, to no longer have it that complex. And what we think what you need to do is that you really abstract over the whole networking, abstract even over the communication. You don't think about what's the stuff that needs to be synchronized, what's the stuff that needs to be sent in messages or something like that. What you do is you have objects that you use as if they were local objects, and basically a program is for you something like this is different threads. It's not different clients. It's not different servers. It's different threads. That's the abstraction we want to achieve in the end. And the way we think is that if you create a meta model over your real code, over your model, you can basically all the time find something like, okay, this is a player, this is an enemy, and basically probably those have components, like in Unity they have a component approach, and this is the way that we think abstraction needs to be in this. And basically, our goal is that you really always can program in the native code you want, like C#, JavaScript, C++, and basically everything. Use objects, use the normal objects you have in your code. You don't need to have anything else, and you use them as if they were local. For example, this is part of a game. You can, for example, or as an example actually, you can change the value of an object, and this will be reflected to everyone that knows the change, and that knows the object. And for example, you can call a function, and it will be called on everyone's client that has this player, that knows this player. And if you do this correct, you can achieve complete language transparency, meaning that if you want to have a new language, you basically only have to add a new language to the generation service instead of programming everything completely new. And the idea is that the distributed object is not only distributed for networking, but across all tiers and platforms, meaning, for example, persistence is something that is part of distributed objects too in our mind, because A database is only something that needs to know the state of the object. So if the name, for example, would be something that is persistable, it would be automatically stored in the database by this call, and even if it's done by a client. If you do this, you have to think about a lot of stuff like rights system. Because if a client can change the name of everyone or something like that, it doesn't work anymore. And if it's then even stored in the database, or if they could change their own money or something like that. So if you do this distributed objects approach, there are a lot of different things that are a problem and that you have to think about. But if you abstract the correct way, then actually you can achieve something better with it. And now we come to the real approach that APlay does. APlay is a technology that is around since 3 years, I think, and we basically started with doing an only peer-to-peer high-performance technology, and decided that it's the best way to make everything as abstract and as easy to use as possible. And those are some of the games that currently use our game, and for example, Jack the Lions Online used our mass testing to a high extent to be able to scale their servers, and that's one of the advantages if you use the APlay approach. The APlay approach allows you to you create classes that are distributed classes, and APlay generates the language you require for those classes, meaning that that you only have to define the class once, and a stub of your class will be everywhere, and you only have to write your platform dependent code actually, and it makes the development of a game a lot easier. And the knowledge of this allows us to do something like the mass testing or a debugger that I will show later. Basically, because we know the whole object model, we are able to give debugging informations on a very, very specific way. We don't say message 3 was sent. We can say player Steve called shoot, for example. We can say where those events landed and what exactly was the impact, how much traffic did it cost, and everything. We can track down on a very, very detailed level what kind of information. We just have a lot of information basically. And what I want to do now is to show you a live demo of what you can do with an approach like this, and this, if I find it. So we are talking about distributed objects, and the point is that if you have distributed objects, you can do a lot of stuff with those objects. It's not like you have an object that is replicated somewhere or something like that, but you have objects with whole hierarchies behind it. For example, if you have a player and the player has a weapon or something like that, you can have a weapon object, and to change a weapon, you probably only have to change the reference to another weapon object, and the weapon itself could cause something like fire. Now let's look at the example. The example is something that's it's very, very easy, and it's very easy to make it easy to explain. It's a Unity sample that we actually changed, and that sample doesn't work that good with dual monitors actually, as it looks. And this is one of the samples of Unity, and you can walk around and can shoot. We disabled everything but the player's movement and shooting in this case to make it very clear and very easy. In this case, you have a player. That player has a position that has a facing direction where you're moving, and you have a moving direction, what keys you're basically pressing and what's the direction you're moving. And this is presented as an object. This is the player in this case, or an actor actually. And an actor additionally has a field that's called mouse down. And mouse down basically triggers the shoot, and that's how you would do something like this in a distributed object mode. And now I'm adding another client. If I did know that I would have internet here, I could have started something that you could download it actually. But basically, you can see those are both in sync. What is important to know is it's more like the like a MMO kind of way. It's like you have a position and you interpolate between the positions. It's very using very few traffic, and it's not sent every frame or something like that. It's actually it's trying to really reduce the traffic and stuff like that. But we're not focused on high performance or high traffic reduction. We're basically abstracting over all those things. And if you want to have something, a low level that is really good in messaging, you actually can use it. We don't care if you want to use something like another third-party library for the low level, for example. And what I can show now is that this is a live demo of, I could actually show the server. We just, there are just two clients connected, and the important thing is we have another thing, and this is a very, very small JavaScript. This JavaScript just shows one of the features that's very easy if you have this distributed model. APlay has a lot of languages. It has JavaScript, it has Flash, C++, and I'm missing out a lot, Java, don't know all at the moment. And we're getting, I think we're trying to get one each month, actually. And if I press on shoot, the state of the player changes to shoot, basically. And all this does is it changes the field mouse down of the player object. And I can call don't shoot, like, for example, the same way. And this is just an example of how you can interact with this stuff. And you can even have a website that is presenting the current health and something of your players, for example. And you can even change how important it is that this data is updated on the website, for example. And another thing that I could want to show is if you use our distributed object model, you even are able to create a web service that gives you access to everything, to your whole object model with basically one click. The basic idea is that if you use this, for example, you can, for example, get the, it's really a bit tiny. You can see the web service is called WS at that point, and the object is actor we're talking about, and we want to get the position in this case. And what we did there is we got a JSON object of the current position this player has. And you could do the same thing, for example, with the current mouse. And you can get, you know, the player currently is not shooting. And you could even change the value of something here via the web service. You get the successful, and you see it's shooting. And basically, yeah, you can basically call everything in this via the web service, and even references to other objects are as a part of the web service. And this is one of the things that you get when using distributed objects. It's actually making it really allows you to do a lot of stuff that is really easy to use and allows you to do things that you wouldn't do without it, actually. And if you use APlay, for example, the way you would define something like this is you only have to define what are the fields that are distributed, for example, in this object. This is just an actor, for example, and has 3 vectors containing the movement direction, the facing direction, and the position. Like I got the position in that case, I could have gotten the facing direction, everything too. And the cool thing is that if you want to change the position of an actor, for example, the only thing you have to do is this line. You only have to change. You only have to set the value in that case. And for example, if you want to create a room where all players are part of the room, you only have to add those actors to the room and by adding it to a list. And in this case, the first line is something that we call permission group. That's something that that I talked about in the beginning. That it's actually important to define who can see what, who needs to receive what, and in this case, the movement can be changed by clients. So you can change your movement direction, you can change your facing direction, and all those stuff, and it's distributed to everyone. So this is why the web service can read this stuff, because it's distributed to all. You can have a list of roles, for example, web service or administrative client, for example. So you could have data that is only visible to the server and an administrative client and stuff like that. And as easy as that, if you want to save something in a database, you can basically just write database before some of those lines, and this will be presented in the database in connection to this user, actually. And just to show you how you would add a web service, the only thing I had to do to get this web service in that example was to click on the left side in our editor and click on create role and select web service, and that's everything. And one thing that is like an Outlook, we are currently developing something that you only have to click to multiplayer enable in game in Unity. We scan for a lot of stuff in the components to find out what needs to be distributed. And if we don't find the correct stuff, you can click on distribute, actually. And there are multiple ways you can distribute data, if it's interpolated, if it's really synchronous, and stuff like that. And so we automatically built an object model for a Unity project, for example. And you can still use it using the normal classes that I explained before. And something, how much time do I have? 5 minutes. Okay. I want to show one other thing very short. Just to show something, another thing that's really cool about if you have distributed objects. Okay, that's really small. This is an example. That's not the game that we saw before, but that's another example. With you can see the different nodes in the system. There was one server and 6 clients, for example, in this case. And what you can see here is the events that happened in that time. And you can go on one of those events and you see what happened. Actually, it's not that beautified. The debugger is not that polished at the moment, but what you can do is you can zoom into and see what happened at that time. You can basically see what was the stuff that caught those. This is creation. This means, for example, it's a creation, and you can see this triggered all those events. You can see the client. This client called a login, and this login triggered all those events. So even if it's getting really complicated, if you develop in the cloud, we enable you to keep track of what happened in the complex system you created. And for example, if you go into the view here, you can see what nodes are existing there and how they are connected. And what you can do is you can go to a given time and you can play what happened there, and you see what events were sent from what client to what client. So you still can find out what happened if something went wrong, for example. Here is, for example, an error in your log. You can post something that is presented in this to find out where it happened. And actually, if it was called out inside of an event from our threads, you actually can find out what call or what distributed call was the root of the problem. And this is just the knowledge we have because of this architecture. So yeah, I said everything about that actually. And the APlay is something that generates code. We have a model and we generate code for you, but at the runtime, it's just native, normal DLLs and stuff and libraries, and you just can distribute it the way you want. Now I come to the conclusion. Basically, we think that it's important that you use high abstraction over basically the whole multi-platform thing and about the low level and everything. And it's just easier to develop a local application than a distributed application. And if you use distributed objects, actually, it really makes it easier to develop something like this. And we think that it's important to use an existing network abstraction. There are a lot of network abstractions out there. There are replication systems, there are RPC systems, and all of them are working as like they should. And you really should consider code generation. We actually were able to do a lot of stuff because of the code generation, and in a lot of cases it really helps to not create bugs and have something that's a lot bigger than it would be without it. Yeah, that's basically it. I think that was it.